This is Algebra 1, Practice Test 7. Let's dive in. In the first set of problems, notice that our instructions say that we can only have positive exponents, just like we normally do. In number 1, we're multiplying everything together. Remember that our general shortcut is when we're multiplying the numbers in the bottom, these base numbers, we just multiply. So 3 and 4, we can just multiply and get 12. And then when I'm multiplying my b and my b, because they are the same exact number, letter, variable, whatever it is, in this case variable, we do this trick where we add the exponents. And let me explain in number 1 at least why we do that again. The general idea here is we're saying altogether this is 3 times 4 times, and I can even make it even more clear than that, 3 times b times b times b times b. This is a long way of writing 3b to the power 4. The power 4 means there's 1, 2, 3, 4 copies. So I have b to the power 4. And then I'm going to, again, multiply this by 4. And then there's going to be 3 b's over here. Times b, times b, times b. These are b's. My 6's are, they're slightly curvy like that. My b's have straight lines. So again, when you multiply, it's the great blender of mathematics. You just squish them all together. When 4 and 3 get squished together, that's 4 times 3, which is our 12. And let me go ahead and erase that 6 so I don't get confused. And then how many of these b's do I have? I have 1, 2, 3, 4, 5, 6, 7 of those b's. So I have b to the power of 7 is a more efficient way of writing that, and I get 12b to the power of 7. That's where all of our properties of exponents stem from. If you just expand everything out, and if you maybe sometimes have b's in the bottom that you can cross and stuff like that, everything, if you just expand it out, it does make more sense. If you're ever confused, expand it out. And if you ask me in class, like, how do you do number 4 and expand it out? I will show you. I'm just showing you the shortcut. So the shortcut in this case was, hey, if you're multiplying, you're going to add 4 and 3. 4 plus 3 is 7. All right, I think I spent enough time talking about 1. Let's go ahead and go a little bit faster with number 2. In number 2, I have 2 times 4, which is 8. Again, that's from this 2 and this 4. And notice I have an x and an x. I have the same base. So I can add their exponents like that shortcut that I was talking about in number 1. I can add 2 and 3 to get 5. So there's a total of 5 x's, or x to the power of 5. And then I also have some y's. How many y's? Well, these are both y's. And then I have 3 and 3. I don't multiply them. Again, I just add them. 3 to the power, or 3 plus 3 is 6. I get my final answer, 8x to the power of 5, y to the power of 6. I am doing something a little bit risky. I'm not checking my work, but I have a meeting here in not too much time, so I need to get through these a little bit faster. But here's the cool thing. If I make a mistake at any time in this video, log the extra credit and tell me. I am going to be super impressed that you get extra credit, and then it just raises your grade. So way to pay attention, way to raise your grade. And number 3, lots of things happening. I have a 2, a 3, and a 3 in the, not denominator, in the base, and I can just multiply those together. 3 times, I'm going to do the 3 and 3 first. So 3 times 3 is 9, and then double 9 is going to be 18. So I have 18. Okay, I have a mixture of x, y's, and z's. I put a little line through my z's so you don't confuse it for a 2. All right, so let's go ahead and count up all of the x's. I have 3 plus 3 is 6, and then there's a hidden 1 there, so plus another 1. 6 plus 1 is 7, so I have a total of 7 of those x's. What about my y's? For my y's, I have 2 and a hidden 1 right here, so that's going to be 3. And what about my z's? I have 3, 4, 5, and then that goes up to 8. 8 z's, and there's my final answer, which I will then box. All right. And number 4, you have 2 separate problems, kind of. You have the 2 divided by 4, and then this x divided by x to the power of 4. So first, I'm going to reduce this fraction 2 over 4, and I'm going to divide both the top and bottom here by 2. When I do that, the fraction reduces to 1/2. That's one of the 2 problems. The second problem is, how do I deal with this x over x to the power of 4? Well, the first thing you have to remember is when you don't have any power up here, you assume that the power is 1. The next thing that you do is you say, okay, well, which of these has more x's? Which of them has a higher positive power? And you say, okay, well, the bottom does. So that's where the answer is going to live. There's only going to be, in your final answer, 1 copy of each letter. Like, look at the last problem. We had a lot of x's. X, x, x. There's only 1 x in our final answer. Same thing in number 4. You're only going to have 1 of these x's, either the top or the bottom. In this case, the bottom one, it was more positive. So x is going to be in the denominator. If your answer lives in the bottom, you're going to do bottom minus top. If the answer had lived in the top, you would have done top minus bottom. So we're doing bottom minus top. You're doing 4 minus 1, 4 minus 1. And there's nothing left over in the top. You have to have a placeholder in the top in order to make this a fraction. Otherwise, if there wasn't a fraction, you just assume this is just living in the top. So we put a 1 to say this is indeed a fraction, and then we can simplify this to 1 over x to the power of 3. So I told you that there are two problems. This problem is a half. This problem over here was 1 over x to the power of 3, but both of these are in the same problem. So altogether, the final answer is 1/2 and 1 over x to the power of 3. I know it's a little bit weird for me to say that they're multiplied. I'm just going to squish them together right now. This is the same thing as 1 over 2x to the power of 3 for my final answer. I think that's the last time that I'll separate problems like that. I'm going to do it all at the same time and jump from here to here next time. All right. And moving on to number 5. And number 5, again, that first part of our question is, how do I reduce 4 and 2? Well, I can divide both the numerator and denominator by 2, and our new fraction is 2 and 1. All right, what about our m's? So I'm specifically looking at m's. I don't see a power here, so you assume that that power is 1. Which one is more positive, 4 or 1? Which one is a bigger positive number? Well, 4 is, which means we're not going to have an m in both the top and the bottom. We're only going to have an m in the top. That's where the m had the higher positive exponent. And then, because our answer is in the top, we're going to do top minus bottom, 4 minus 1, which is 3. And now we have to figure out where our n is going to go. So I have an n in the bottom and the top. Which one is the higher positive number? Well, it's a tie. It's a tie between top and bottom. So the easiest way of explaining this is they cancel out. You just cross and cross. Whenever you see the exact same thing in the top and the bottom, you cross them off and you're done. Technically, it goes to 1. It goes to 1, and 1 times anything is nothing, which is the equivalent of saying, hey, cross it off, cross it off. There is another interpretation if you'd like that. Another perspective is say, well, if it's a tie, put it wherever you'd like. If you want to put it in the bottom, sure, put it in the bottom. And then you're going to do bottom minus top. 3 minus 3 is 0. And then this is going to turn into 2m to the power of 3 over 1n to the power of 0. And anything to the power of 0, this thing is 1. So our new answer is going to be 2m to the power of 3 all over 1 times 1. 1 times 1 is 1. And anything over 1 is just 2m to the power of 3. It's just itself. So that's a long-winded explanation, which is the typical reason I don't use that. Usually I just say, hey, cross it off, and you're good. So I'm going to go ahead and leave that in the notes. Cross it off, they're the exact same thing. So I only had to worry about the m. I could have jumped from here to here almost immediately. All right, what about number 6? There's no number out front. There's no coefficient, so I'm just going to leave that 2 in the denominator. Let's go ahead and write our fraction. The 2 is going to stay in the denominator. Now, for each of these letters, you're going to look at it as a separate problem. And notice that you're missing some powers up here. So let me go ahead and add those labels. Technically, if I zoom in here, this was a power of 1 and a power of 1. Now, each of these variables has a power that's clearly visible. From here, I'm going to look at x to the power of 4 over x to the power of 1. Notice that the numerator has a variable with an exponent that is much more positive, much higher than 1, so the answer for x is going to live in the top. It's going to live in the numerator, wherever it's largest, right? And then I'm going to do, because our answer is in the top, I'm going to do top power minus bottom power. 4 minus 1 is 3. Okay, let's look at the y's next. So if I'm looking at y to the power of 3 and y to the power of 2, notice 3 is bigger than 2, which means our y is going to live in the top. And because our answer is in the top, we're going to do top minus bottom. 3 minus 2 is 1. And then finally, we're going to do our z's. I have a z to the power of 4 and a z to the power of 1. Again, the top has a higher power. So the z is going to live where the higher power lives, in the top. And then I'm going to do top minus bottom. 4 minus 1 is 3. And I'm almost done. Usually we don't write this power of 1. So the final simplified answer here is going to be x to the power of 3, y, z to the power of 3, all of that divided by 2, final answer, and box it. If you write the 1 on the test or the quiz, I guess their test is coming up. This is the practice test. I don't think I'm going to take off points because technically you're correct, but I really want you to simplify it a little bit more. All right, maybe I'll just take off like half a point. If it's this was a bigger problem, but if it's like a really small problem, like one of these, and you leave it off, yeah, I'm still not sure how I'll grade that. I'll address that before the test is given. All right. What do we have down here? So there's a bunch of cool tricks that you can do. Because you have multiplication, you can cross off anything that looks the same because of this multiplication. If this had been addition, you're not allowed to cross things off. But it's multiplication, so we're allowed to cross things off. Do you notice anything that looks the same in the top and the bottom? I do. The first thing that popped out to me were these 3's. If they're the same in the top and bottom, cross them off. You still have this n to the power of 2 and n to the power of 2, and oh, those are the exact same things too. So we can cross off n to the power of 2 and n to the power of 2. And do you see something else that we can cross off? I do. Look at n to the power of 3 and n to the power of 3. Those are exactly the same. So we can cross off n to the power of 3, n to the power of 3, and look at what this problem has become. This problem now says 4 in the top. That's the only thing left over. And what's left over in the bottom? 2. That's it. And I can simplify that really simply by dividing both the numerator and the denominator here by 2, and I get 2 over 1, which is more simply just 2. Anything you see that is multiplied in the top and the bottom, cross them off. All right. Number 8. Again, I'm going to use that same trick of, do you see something that's the same in the top and the bottom? I see a 4 and a 4. Those are the same. Cross it off. Cross and cross. Do I see anything else that's the same? No, I don't. One thing that is weird to me, though, is I have a double y in the bottom. Usually the bottom will only have one type of variable, but I have 2 variables. So before I start doing my subtraction of 4 minus 2 to put the x in the bottom, I'm going to go ahead and simplify the bottom. I have a y and a y that's being multiplied. Our shortcut states if I multiply, I'm going to add these powers. So let's go ahead and rewrite this. In the denominator, notice I have a coefficient that I'm going to write first. I have a 2. And then I have an x to the power of 4, which hasn't gone anywhere. Again, I'm going to just copy down this x to the power of 4. But I have a y to the power of 4 and a y to the power of 4. I'm going to add their exponents because we're multiplying the bases. I have y to the power of 8. All right, and I'm going to rewrite that numerator without that 4. I'm just going to say this is x squared y to the negative 3. All right, now I'm ready to simplify. Notice that I still have 2 copies of the x, which means I'm not simplified all the way. I need to only have 1 copy of the x. It needs to either live in the numerator or the denominator, either the top or the bottom. Notice in this case, the 4 is bigger than the 2, which means our answer is going to live where the bigger exponent is. So it's going to live in the denominator. So with my fraction, I still have that 2. The x is not going to live in the top, but the bottom. And because my answer is in the bottom, that scared me. It's my alarm saying, get ready for your meeting. I'm going to do bottom minus top. I'm going to get 4 minus 2, which is 2. And then notice for our y's, I'm going to do the same thing. I have a bigger power in the denominator. It's a bigger positive number. So my y is also going to live in the denominator. And I'm going to do bottom minus top. I'm going to do, and I'll be careful here, it's 8 minus the top. And the top is negative 3. So there's a double negative happening. Whenever there's a double negative, it's really adding negatives kiss and become positive. Nothing was left in the numerator. And in order to keep this a fraction, we need a 1 up there. So more simplified, I can say that this is 1 in the numerator, all divided by 2x squared y to the power of 8 plus 3 is 11. Final answer, and box it. That's our first of 3 pages. All right, on to the second page. All right, in number 9, we have a power and 2 bases. Any bottom number down here is a base, and because I have 2 of those bases, I do need to distribute. So this is going to turn in for my first step as 3 to the power of 3, that's the first distribution, and x to the power of 3 also to the power of 3. I've now distributed that 3. And then from there, I can say, okay, 3 to the power of 3. If you don't know how to do that, 3 times 3 times 3. There's 3 copies of that. 3 times 3 is 9. 9 times 3 is 27. So 3 cubed is going to come down here to 27. All right, and what do I do with these x's? I have a power to a power. What operation are you supposed to do? Are you supposed to do addition, multiplication, division, subtraction? What do you do with the 3 and the 3? You multiply. A power to a power always means multiplication. 3 times 3 is 9, and there's my final answer, 27x to the power of 9. All right, we're on to number 10. Look at how many bases we have in this case. 1, 2, 3 of these bottom numbers, so I'm going to have to distribute 1, 2, 3 different times, and I'm going to get 4 squared, x squared, and it was originally a y squared, which is again going to be squared. I know how to do 4 squared. That's 4 times 4, which is 16. I know that x squared isn't going to change, and now I have to be careful. What operation do we do when it's a power to a power? As is the case in number 9, this is also multiplication, and I guess if you did addition, you might have accidentally got it correct as well, but it's going to be y to the power of 4. Y to the power of 4, and that's all I can do. Final answer, and box it. Again, y is all I can do. I have 1x, 1y, and my number up here has been expanded. Although if you had left it 4 squared, I would have given you full points. Number 11. All right, be careful with your orders of operations. Do I do the multiplication first and try to combine these first, or do I do a power first and try to combine those first? The answer is PEMDAS. Please excuse my dear And Sally, you are supposed to do anything in parentheses first. Well, everything inside the parentheses is done, so check. And then exponents next. Well, this is an exponent, which means this is the thing that's going to happen next. So I'm going to not move this v to the power 4. That hasn't changed. But this v over here is going to change. What operation do we do when it's a power to a power? We multiply. 3 times 2 is 6. And again, there was an original multiplication between those two symbols. Whenever I multiply the bases, I add the exponents. So 4 plus 6 is 10, and I get v to the power of 10 for my final answer, which I'll box. In number 12, I'm going to first, wait. I see something that's the same. 3 and the 3, I see the same thing. Cross it off. Cross off the 3, cross off the 3, and you might be thinking, I see a 2 and a 2. No, -2 is not the same thing as a 2. You can't cross those off, sadly. But what I can do is I can rewrite this problem and make it a little bit easier to read. I have a 2v squared times v to the power of 4 all over v to the -2. All right, well, typically the way I like to solve these problems is to simplify the numerator and simplify the denominator. Sorry about that. Denominator can't do anything with, but these I can simplify to just 1v instead of 2v's. So I'm going to have 2v to the power of, okay, I'm multiplying the bases, so I'm going to add the powers. 2 plus 4 is 6, and this is still divided by v to the power of -2. There are two ways to approach this problem. Let me show you both different ways and let you choose whichever one you would like. The first way that I see of doing this is to choose which of these powers is bigger positive. And you say 6 is the bigger positive. So that means the v is going to live in the top and there's not going to be anything in the denominator. I still have that 2 out front, and I'm going to do top minus the bottom, and the bottom is -2. And then from there, you would say, okay, this is going to be 2v to the power of 6. Again, double negatives kiss, become positive. 6 plus 2 is 8, so 2v to the power of 8. And because it's divided by 1, we don't write the divided by 1, we just write 2v to the power of 8. That is one way of thinking about it. Another way of thinking about it is to say this is 2v to the power of 6, and I'm going to flip this v to the power of -2 and bring it to the top, and this is going to be v to the power of positive 2. If you do that, then I'm going again, these are being multiplied, right? I'm going to add these powers, 6 plus 2, and I'm going to get 2v to the power of 8. It's the same answer, it's just a different path. I don't care which path you choose. There's a lot of different ways to do the math. All right. In number 13, what do we have? I have this -2. I'm going to have to distribute you first. So let's go ahead and do that. -2 to each base, to the m and to the 2. That's going to be 2 to the -2, m to the power of 4, also to the power of -2. All of that divided by 2m to the power of 4. All right, this is one of the most common mistakes as of right now. Most people will say, oh, did you know that this is equal to -4? You are incorrect. You will never have a negative out front, ever, in any of these problems. I don't think I'd do that ever. Maybe on an old homework assignment, but not on a quiz and not on a test. Your answers will never have a negative. Negative powers simply mean you go to the other side. If you were on the top, you go to the bottom. If you were on the bottom, you would have gone to the top. So before I do that, though, I want to go ahead and simplify the 4 -2. When I have a power to a power, I multiply. So this is 2 to the -2, m to the power of -8. And then this is all divided by 2m to the power of 4, which has not changed. From there, we are going to move this down to the bottom and this down to the bottom as well, because they both have a negative power. When we bring them to the denominator, they will now have a positive power, which means there's nothing left in the numerator. So I'm going to say the numerator is 1. In the denominator, I originally had a 2m to the power of 4, but now I also have a 2 to the power of now positive 2 instead of -2, and an m not to the -8, but positive 8. And now I'm ready to simplify this a little bit more. It's still going to be a 1 in the numerator. 2 squared is 4 times 2m to the power of... Okay, we'll check this out. I have an m and an m. If they're the same base, I add their exponents due to the multiplication. So 4 plus 8 is going to be 12. And notice I'm multiplying 4 times 2, which I, again, can simplify to 8. So this is going to be 1 over 8m to the power of 12. Final answer, and box it. In number 14, there's no way out of it. I'm going to have to distribute the -2 into both the base of the n and the base of the 2. So this is going to become 2 to the power of -2, n to the power of -1, also to the power of -2. In the denominator, I can simplify just a little bit. Again, you're doing your exponentiation before your multiplication. So I'm going to say leave the n to the power of 4, and I'm going to say this is now n to the power of, you multiply 2 times 3, and you get 6. From here, we can simplify a little bit further. I'm going to leave the 2 to the negative 2. We'll deal with you in the next step. And I'm going to multiply these powers. A negative times a negative is a positive, and 1 times 2 is a 2. So it's n to the power of positive 2. In the denominator, I can simplify yet again. Because of multiplication of the same bases, I can add the exponents 4 plus 6 and get n to the power of 10. All right. The next thing to do, I'm going to do 2 things at the same time because you guys are getting better and better at this. Because I have a negative power, I'm bringing you to the denominator. This is now going to be equal to, I have 2 to the power of positive 2 in the denominator. What do I do with these n's? Well, now it's time to choose which one is the bigger positive. This one is the bigger positive, which means my answer, n, is going to live in the denominator, in the bottom. And then because it's in the bottom, I'm going to do bottom minus top, 10 minus 2, and I get 8. And that means there's nothing left over up here, and in order to keep it a fraction, I need to have a 1 up there. While this will give you full points on a test, I would like you to know how to simplify 2 squared. 2 squared is 4, so it's 1 over 4n to the power of 8 for my final answer, which I will then box. Then I move on to number 15, and oh dear gosh, maybe 16. That looks pretty hard. I got some zeros in there, which is making me happy, but still, that looks gross. All right, and number 15, how do we approach this problem? Well, I'm noticing in the numerator, I have a copy of a b and a b. Usually, I only want one b in the numerator and one a in the numerator. I only have one a in the numerator, so I'm going to go ahead and simplify those. So here we go. I'm going to still have a 2. I'm still going to have an a to the power of 3. Nothing, I mean, that just came over here. That just came over here. The only thing I'm going to do now is I'm going to do something to these. I'm going to say this is going to be b to the power of, because they're being multiplied, I'm going to add their exponents. Negative 4 plus 2 is a negative 2. What about the denominator? For the denominator, this 3 is going to be distributed to the base of b, the base of a, and the base of 2. There's 3 distributions that are going to happen here, and I'm going to have 2 to the power of 3, a to the power of 4, also to the power of 3, and b to the power of 3, also to the power of 3. And we'll extend that line over a little bit, but not that far. All right. From here, I can't do anything to the top. You might say, oh, look, they're the same and same. Well, no, that 3 is technically attached, so that is not the same as that. Not yet. So from here, I'm going to leave the top the same. I'm going to say this is 2a to the power of 3, b to the negative 2. And then in the denominator, I can say 2 to the power of 3. I know that's 2 times 2 times 2, and 2 times 2 is 4, and 4 times 2 is 8. So I'm going to go ahead and say that's going to be 8. And I'm going to simplify it. Whenever I have a power to a power, I multiply it. And I'm going to get a to the power of 4 times 3. 4 times 3 is 12. And b to the power of 3 times 3, and that's going to be 9. All right, I'm doing really well for myself. I need to come down here, maybe in a second color, and I need to simplify 2 over 8. So I want to do that with pen. I'm going to divide the top and bottom by 2, divide by 2, and I'm going to get 1 over 4. All right, what am I going to do with these a's? Well, choose the more positive. That's the more positive, so the answer is going to live in the bottom, in the denominator. And because I'm leaving it in the bottom, I'm going to do bottom minus top. 12 minus 3 is going to be 9. All right, from there, I'm going to work on my b's. Which one is the more positive between the power of 9 and negative 2? Well, 9 is the larger positive, so my answer, again, is going to live in the bottom. And I'm going to do bottom minus top. And be careful here, because you're really doing 9 minus a negative 2. So when I'm doing a negative 2, negatives kiss and become positive, and my final answer can be written as 1 over 4a to the power of 9, b to the power of 11 for my final answer, which I will then box. Moving on to, I think, the last properties of exponents problem on the practice test. This monstrosity. Okay, well, the first thing that I'm seeing is a power of 0. Those are my favorites because you just scribble them out. Scribble that p to the power of 0 out. It goes technically to 1, and 1 times 2r is just the 2r, which is the equivalent of scribbling it out. I know it's tempting to try to distribute the 2 right now, but that looks disgusting. Let's go ahead and simplify that before we distribute the 2. That'll make our lives much easier, so we'll not forget about you. What do I see in the bottom? My eyes are first drawn to the fact that I have a P, an R, and an R. I have a bunch of these copies. I only have one Q, so the Q has already been simplified for the denominator. So in the denominator, well, I guess I'll leave the numerator alone. Numerator is still 2R. Haven't touched you. In the denominator, I have a 2 and a 2. 2 times 2 is 4. Let's look at all the R's. So I have an R to the power of 1, R to the power of 1. And because everything is being multiplied down here, I'm going to add 1 plus 1. I'm going to get r to the power of 2. Again, that q is not going to move anywhere, so q is going to be to the power of 4. What about the p's? So look at the p's. I have a p to the power of -2, p to the power of -3. Again, multiplication is happening, so I'm going to add -2, add -3. And just as a side note, if I have -2 and I'm adding a -3, really this is the same thing as -2 minus 3. And notice these are the same sign. Same sign means add and take the sign larger. If I add that, I get a 5. Take the sign larger, it's a -5. Notice this looks much simpler than that. I mean, at least a little bit. I got rid of like 3 different symbols, right? And now I have to distribute the 2. So this is still all to the power collectively of 2. I have to, wait, do I have to yet? No, I can still simplify the inside. Check it out. Did you know 4 and 2 can be simplified? Did you know r and r squared can be simplified? All that stuff is going to stay down there, but these can be simplified. Let's do that before we do the 2. I don't want to jump the gun. I'm going to make the inside as easy as possible before I take it to a power. Otherwise, my life is going to be miserable. All right, I'm going to divide this 2 by 2, divide that 4 by 2. I've divided the top and bottom by 2, so it's now a 1 and a 2 instead of a 2 and a 4. Notice this r up in the numerator was a 1, and this r in the bottom was a power of 2. Which of these is a bigger positive? That one. So that's where r is going to live. R is going to live down in the bottom, and I'm going to do bottom minus top. This 2 minus 1. 2 minus 1 is 1. And I rewrite the rest of everything. I have a q to the power of 4, p to the power of negative. Wait a second. I can make that even easier. Whenever I have a negative power, doesn't that mean flip? Let's go ahead and flip u up to the top. I'm going to say you are going to come up here, and this is going to be p to the power of not -5, but +5. And now that's still all to the power of 2. Okay, I can't get the inside any more simplified aside from just crossing off the 1. Now it is officially time to distribute this 2 into each base. I'm going to ignore that 1 for a sec. The 2 is going to come down into the p. The 2 is going to come down to the q. The 2 is going to come down to the r. The 2 is going to come down to the 2. Every single piece on the inside has to be to the power of 2. Sure, you want to put the 1 to the power of 2? Sure, go for it. You'll still get the same answer. Check it out. I'll get 1 squared. P to the power of 5 squared. I will get in the denominator 2 squared. R to the power of 1 squared. I'll have a q to the power of 4 also squared. I realize there's ways to simplify that and that a little bit faster, but I'm just being pedantic. I'm making sure you really understand what's going on. Did you know 1 squared is equal to 1 times 1? And did you know 1 times 1 is 1? And did you know that 1 times that thing is that thing, which is the equivalent of scribbling that out? Yeah, so I just have this in the numerator. In the numerator, I just have p to the power of, okay, what do I do for my operation with the 5 and 2? Do I add them? No, I multiply. A power to a power means multiply. 5 times 2 is 10. And in the denominator, I'm going to have a 4. I'm going to have an r to the power of, okay, multiply. 1 times 2 is 2. And again, multiply q to the power of 4 times 2 is 8. So it's going to be q to the power of 8. And we are finally done. Here's how I know we're done. I've simplified the fraction. I only have 1 copy of p, 1 copy of r, 1 copy of q. I cannot go any further, and notice that all of my powers are positive. Again, if I've made any mistakes, it's more likely that I make a mistake on a Harvard problem. Please let me know. You will get extra credit. I am on to number 17, and for these, I say that a calculator is required. You don't need to, but I'm going to be using one. I want to go faster here. I have a meeting that's happening here in like 14 minutes, so I got to speed through these things. All right. This is how we do these problems. I'm going to say this is 9 point... Okay, hold on. Let me make the distinction. If there's no sign in between, you assume it's multiplication. And as I've said before, multiplication is the great blender of mathematics. You just squish everything together in any order that you want. I'm going to put 9.7, and then I'm going to put 1.5, and then I'm going to put 10 to the negative 1, and then I'm going to do 10 to the negative 2. I just kind of switch them around a little bit and drop the parentheses. You're allowed to do this. I'm going to use a calculator for this bit right here. So give me a sec. I'm going to pull up my scientific calculator. I'm probably going to have to clear things from last time if it opens. Oh, no, it's ready to go. So I'm going to split you with you, and you don't need to be so big. All right, so I want to know 9.7. I'm going to multiply you by 1.5, and I get 4, and 10, please. I'm going to get 14.55. What happens to all of this over here? Well, over here, I have the same base. Whenever you have the same base, you add the exponents due to the multiplication. So -1 plus a -2 is a -3. So this is going to be times 10 to the -3, which seems like it's the final answer, but it needs to be in scientific notation, which means the decimal place has to be right after my first number. I need to move the decimal place from here to here, which I'm going to write in pen. I need to move the decimal place 1 to the left, which means I'm going to get 1.455. And because my number got smaller here, this number over here got smaller. It was 14, now it's 1. This number has to get bigger. This number has to get bigger, so I'm going to add 1 to it. I'm going to get times 10 to the power of negative 3 plus 1 is negative 2 for my final answer, which I will then box. You'll notice that I do write my multiplication symbol as an X like they do down here. Even though it annoys me, I'm still going to do it. All right. You don't have to worry about rounding for these until you have a bunch of extra decimals. All right. How do we do this problem? In this problem, I'm going to do 8 divided by 1.4 as my first problem. So let's go ahead and, calculator, help me out here. I have 8 divided by 1.4. So that's going to be 5. Okay, so now I have to worry about rounding. And typically for rounding, 3 decimal places will usually get you the right answer. So 5.714. The next number is a 2, so I don't round that 4 up. And then this is going to be times 10 to the power of, and then it's because it's the same base with division. I'm going to do subtraction. I'm going to do top minus bottom because my answer is going to go in the top. Or off to the side is the same thing as the top. So I'm going to do negative 1 minus the bottom, which is a negative 2. Double negatives mean I'm going to add. And this is really, well, look, they're the opposite signs. One's a negative, one's a positive. Opposite signs mean you subtract. 2 minus 1 is 1. Take the sign larger, it was positive, and it's a positive 1. So this is going to be times 10 to the positive 1. And we don't need to move the decimal place. The decimal place right here is excellent. I didn't have to go left or right, which means that's our final answer, and I can just box that right now. Lucky us. All right. Number 19, whenever you have a power up here, this power is going to be distributed to each of the bases inside. So the way that I show my work is I say this negative 1 is going to go to this base and to this base, and I'm going to get 6.74 to the negative 1 times 10 to the negative 3, all of that quantity to the negative 1. I'm going to deal with that 10 first because I just want to. A power to a power means you multiply. Multiplying a negative times a negative is a positive. This is 10 to the power of positive. I was about to say 4. I don't know why I was thinking 4, but it's positive 3. 3 times 1 is 3. And then over here, I don't know what that is, so I use a calculator. I'm going to say this is going to be 6.74 to the power of, so to the power of negative 1. And I get this decimal, 0.148. I'm going to round that 3 up to a 4. And you might be wondering, Mr. Sindel, why did you do 4 decimal places instead of 3? Because I can look into the future. I know I'm about to move that decimal place 1 to the right, and I'll have 3 decimal places after I move my decimal place. So, as I said, I'm going to move that decimal place to make this in scientific notation. Scientific notation needs a leading number other than 0. It needs to be like a 1 or a 9 or something like that. 1 through 9 is fine. You can't lead with 0. So I'm going to move the decimal place, and I'm going to get 1.484. There's 3 decimal places of accuracy. And this is going to be times 10 to what power? Well, again, think about it this way. I had a number that was 0, and now I have a number that's 1. This number got bigger, which means this number must get smaller by the number of places that I moved the decimal place. I moved 1 decimal place, so then it needs to get 1 smaller. So 1 smaller is 2. And there's my final answer, which I will then box. We're on to number 20. Kind of the same thing. You're just going to distribute the 3 into that base, and this is going to be 6 to the power of 3 times 10 to the power of 3, also to the power of 3. Again, I want to deal with that 10 to the power of stuff. Power and a power means multiply. 3 times 3 is 9. That was easy. And 6 to the power of 3 is like 216 or something. Let's see. 6 to the power of 3. Oh, Mr. Sindel, I am on it today. 216. All right. Unfortunately, this is not in scientific notation. Right now, the decimal place is hidden, but it's technically after the 6. And I need to move that decimal place 2 jumps over here. So this is going to turn into 2.16 times 10 to some power. Notice, I used to have a number that was 216, and now it's 2. It got smaller. If this number got smaller, this number has to do the opposite and get bigger. This number is going to be plus 2, and I'm going to get 11. So there's our final answer, 2.16 times 10 to the power of 11. And then we have our last 2 problems on our practice test. Here we go. The only thing that you really need to be careful of in these last 2 problems, first, make sure these 2 numbers are the same, and then do whatever that operation says to do. Notice that neither of these numbers are the same, which means we've got some work cut out for us. So you get to choose whatever you want to do. I'm going to randomly say I'm going to choose the bigger number. Usually that's worked out better for me, but if you choose a smaller number, that should still work. It means you probably have one additional step at the end. So I'm going to change this to times 10 to the power of 3 instead of 2. I'm going to leave this 7 times 10 to the power of 3. I'm not going to touch you. If I'm changing my power of 2 to a power of 3, this number got bigger, which means this number has to get smaller. Instead of 4, I'm going to make it 0.4, moving the decimal place from here to right there, and it's going to be 0.4. Notice, now after rewriting these with the same power, this is not in scientific notation anymore, but because I have the same power, I can add these two numbers. 7 plus 0.4, and if you don't believe me, I'll write this out very long. 7 plus 0.4 is 7.4. And you keep the times 10 to the power of 3 for my final answer, which I will then box. Remember, your answer should always be in scientific notation, which this one is because I have a decimal place right after a number that is not 0. Last problem, here we go. I don't even need a calculator. Come on, we got this, right? Famous last words. All right, so I need these numbers to both be the same, and I choose the bigger number. It typically works out better for me. So I'm going to keep the bigger number. You are going to get bigger. You are going to be times 10 to the power of 4, madame. And if this number is getting bigger, this number needs to get smaller. It was 2.5, and now it's going to be 0.25. So it's moving 1 to the left because this number got 1 bigger. And I'm going to rewrite everything over here, minus 1.9 times 10 to the power of 4. All right, we've unlocked the ability to actually do this operation because this power and this power are the same. So I want to do 0.25 minus 1.9. The problem with that is it's hard to do. As a general rule of thumb, for all subtraction problems, you always do big minus small. And then that's step 1. And step 2, take sign of big. Do I have enough room over here? Oh, I don't know why I was squishing it in here. Take the sign of the bigger number. So my bigger number is 1.9. My smaller number is 0.25. So I'm doing big minus small, filling in the zeros appropriately. When I do my subtraction problem, my decimal place is in line right here. And then I'm ready to go. I need to do some borrowing. I can't do 0 minus 5, but I can do 10 minus 5 if I borrow from you and turn you into an 8. And I'm ready to go now, right? So 10 minus 5 is 5. 8 minus 2, 7. 1 minus 0, 1. Excellent. And from here, did I just really say 8 minus 2 is 7? My brain is just not on it right now. All right, 6, and then 1. Okay, this feels a little bit better. And, okay, look at this. Step 1, check. Step 2, not check. Okay, take the sign of the big. Which of these was big? That was big. What sign do we have? Negative. So I take the negative sign, ooh, pen, and I get negative. And don't forget, we still need to copy down whatever that one was, and these are both 10 to the power of 4. Whoa, did not mean to do that. So this is going to be times 10 to the power of 4 for my final answer, which I will then box, and I think that's it. Again, remind me if I made any mistakes. That concludes our practice test for Algebra 1. Thank you for watching.